This is the way it looks when you look at the relationship between pressure and volume.
Why does that screen
So when I multiply pressure times volume, I get a constant. Okay? But if I change pressure, volume is going to be forced to change as long as the temperature doesn't change and the amount of gas doesn't change. Okay? So if this is the first pressure and volume, whatever I started with, pressure 1 and volume 1, then I'm going to also have pressure 2 and volume 2 that equals K. Whenever I change the pressure or the volume, the other variable also changes so that it always equals K. That whatever that constant happens to be. Okay? Well, then what we could say is that pressure 1 times volume 1 equals K, which also equals pressure 2 times volume 2, and mathematically that means that pressure 1 times volume 1 equals pressure 2 times volume 2. And this is the most practical form, usable form, of Boyle's law for us. Okay? And as I said before, the relationship when you plot it, and you did this in a lab last week, looks something like this. Okay? It's an inverse relationship. I mean, from Unit 1, you're supposed to know what an inverse looks like.
Yeah.
So if you ever see this pattern when you're doing experimentation, you could say, oh, that's inverse. Okay? That makes sense? This is Boyle's law.
Oh, right.
This is Boyle's law. Okay? Now, there are a couple of caveats here. All right? You cannot change.
What does caveat mean?
It's kind of an if and only if kind of statement.
All right. It's Latin.
You cannot change the amount of gas.
That's English.
Okay? And since the SI unit for the amount of substance is the mole, therefore you cannot change moles. The number of moles.
Right, right.
And we symbolize in our gas laws the number of moles as the letter N. Okay? The English language and the Greek language mostly.
And number of moles.
There you go. N, number of moles. Very good. All right. The other thing you can't change is when we're looking, when you're looking at a pressure-volume relationship, when you're looking at pressure-volume relationships, you also cannot change the temperature. If you change the temperature, then that's a different relationship that gets into a different law. Okay?
Like Charles' law?
Like Charles' law.
Yeah.
Or Gay-Lussac's law.
What's that?
Or the combined gas law.
Wait,
Or Gay-Lussac's law.
Gay-Lussac's law, right.
It's two different guys. One guy's named Gay and the other guy's named Lussac.
Lussac.
Okay.
Josh, what's so funny?
Josh didn't say anything. Jay Breezy thinks something's funny.
Oh, Jay Breezy, what's so funny? Hey, zebra, shut up. What animal is this? Oh, it's like a zebra mixed. It's a hybrid.
Black and white is my favorite color. So,
Black
black and white is your favorite color. They are.
How are two colors not one color?
Colors, then. Well, because they go together. You know, you can't have black and white. Or white.
Yeah, you can. You have black and red.
Not when it comes to wearing clothes.
Well, yeah, clothes are overrated. If it's cold outside and you get your clothes wet, you're going to be colder. So it's better just to go naked when it's cold.
Black and white isn't serious.
Misha, you and Thompson fight.
What?
Didn't you see zebra?
No.
Yes, I like them a lot.
All right, you know, instead of talking about things like that, y'all should really be writing this down with me.
We just want to have fun.
I know you just want to have fun, but I just want you to pass my test
When's our test?
tomorrow.
No, he's lying. We haven't even done unit 2.
You're right. We're not going to have it tomorrow.
Oh my gosh.
But you guys know that I don't decide on when we're going to do tests till I
You
finish
just made me have a
teaching the
heart
material.
attack. Is that 700%?
You haven't had a heart attack.
I'm about to have a what?
Ah, my left arm hurt.
Now, you might be having a heart attack, but he's not having a heart attack. What?
You might want to put this on pause.
Tom, you can't use a calculator.
I can't put it on pause.
Cheater.
Okay. Well, can you get Tourette's at a late age?
What?
I have no idea.
Because, like,
Okay, I have no idea.
okay.
But if you just start
It's okay to
if you
get-
just
you
start
can't get Tourette's.
speaking wild things in here, I still have to write you up. Okay. Tourette's or no Tourette's, unless I have a doctor's excuse. You know, I've had students with Tourette's before. I kind
Have
of
you
know
seen
what.
the Tourette's version of South Park?
Do this. Please write this down. Please write this down. Do your work first.
Yes.
Then having
sir.
fun is okay.
Yes, sir.
Is that if the temperature?
If the temperature remains constant. So I've given you the conditions here. Okay, I said that in order for Boyle's law to work, we cannot change the amount of gas. So I said a fixed amount of helium. So I didn't change the amount of gas. All right. We said also that the amount of a substance is measured in moles. So the moles are going to stay constant. Okay. And then down here I said the result. What pressure will result if the temperature remains constant. So I've also said that we're not going to change the temperature. So I've set the conditions for you. Okay, the only variables that are changing are pressure and volume here. Okay? Now let me show you how I expect you to solve these problems. Okay? This isn't optional. This is how I expect you to solve these problems. Because as we get into more complex problems, this process is going to save your, bacon. Okay? Bacon. All right? What? Oh, yeah, I do need a question mark. You're absolutely right. Okay. That's why I don't teach English, I guess. Okay.
If you email him that, then
No, it's not in the handout. So, all right. So here's what I expect you to do when you see a problem such as this. Okay. And I've been telling you all semester what a wonderful device this is. A pen or a pencil. Writing devices. They're so cool because they allow you to keep a record of everything you're working with so you don't forget what you're doing. Okay? So what I want to do is go through this problem and identify all of my potential variables, knowns I'm going to call them, and what is unknown in this problem. Okay? A known value here is a volume of 2.55 liters. Okay? So I'm going to list that. Volume of 2.55 liters. Okay? We use a capital L for liters, just to remind you this is a Unit 1 subject, capital L for liters, only because it's hard to tell what little L's mean.
Yeah, they could be I's or ones or
Right.
little lowercase I.
Okay? All right. I'm also telling you we have a potential variable of torr, which is measuring, it tells you there, it measures pressure. So that's P for pressure. Okay?
you ever seen the movie Thor? The movie-
I have not seen Thor, no.
the movie Thor.
Okay? It also says here, if the volume is decreased to this, 1.47 liters, so this is a different volume, same gas.
Right, right.
If it's a different volume, same gas, then I've got to say this is volume 1, this is volume 2.
Right.
Okay?
Yep.
And we're going to lower it to 1.47 liters.
Right.
Does it
Okay.
matter which one's one and which one's two? Or
Not really, but you have to keep your pressure and volume the same, and your next pressure and volume the same. So you got to associate this volume with this pressure. So if you call this V2, you've got to call this P2 because they go together. Okay? And then it asks you what pressure will result. Okay? Well, that means that's an unknown we're trying to find. And if we have a new pressure, that has to be pressure 2, and that's pressure 1. Well, this is, we don't know that one. It's a question mark. Okay? All right. Now, just to make our math a little bit easier, we could solve this easy enough, but let's put a decimal place here. I meant to put one there, and for some reason I skipped over it. Okay? Make our math a little bit easier here. Okay? Is that okay? Everybody catch that, what I said? You're not going to miss it, are you? All right. We have listed now all of the knowns and the unknown. We've listed all the knowns and the unknown. The next thing that you're required to do in this class, again, it's not optional, you must do it, is you want to write the gas law equation that fits this set of variables that we have here, this known and unknown set. Okay? So we're going to write P1 V1 equals P2 V2. When later in this unit, when we've got like 4, 5, 6 different gas laws to work with, writing them out like this is going to help you figure out which gas law to use. Okay?
Do we have to know all the, do we have to memorize?
No, if you look on your test references, you'll find that they're all listed there, they're just not named. So while this gas law is listed in your references, the name of that gas law is not there. You have to know that's Boyle's law. Okay? All right. So now what we're going to do, now that we have our knowns and unknowns listed here, we're going to substitute for the known values the actual values. So we're going to rewrite the equation with the actual values plugged in there. So for P1 here, I'm going to write 7.75 torr. Okay? And for V1, I'm going to write 2.55 liters. And I got an equal sign here. On the other side, I don't know what P2 is, so I'm just going to write P2.
So it's like an algebraic equation.
It's exactly an algebraic equation.
Boom!
Okay? And so for V2, then we're going to write in 1.47 liters. That's why Algebra 2 is a prerequisite or co-requisite for this class. Okay? It means you have to be either have taken it before you take this class, or you have to be registered in Algebra 2 at the same time you're taking this class. Okay?
Gotcha.
All right. Now, solving this problem is a little bit different than maybe you're used to. Okay? I want you to forget you were ever taught anything about cross multiply and divide.
Oh, gosh, I got to get out of my head.
It doesn't exist in here. Okay? Just forget about it. Just forget about it. Okay. What we're going to do is we're going to use a process called isolating the unknown. Well, the P2 is our unknown. And the way you isolate it is to divide both sides of the equation by the thing that unknown is multiplied by.
Yeah.
So we're going to divide by 1.47 liters on both sides.
Yeah.
Okay? Well, before we do that, though, we're going to, there you go, cancel as you go.
Cancel as you go.
Well, in this case,
As you go.
this can cancel the whole thing there. And we've isolated the unknown. You see that?
Right. Yep,
We've got it by itself.
Yep,
We've
right.
isolated it.
Uh-huh.
All right. On this side, I can cancel liters.
Right.
Now, here's the beauty of this process. This is dimensional analysis again,
Mm-hmm.
okay, but just used in a different setup.
Uh-huh.
The units of measurement I have left are the units of measurement called torr, and I set up here that torr measures pressure, and I'm trying to find pressure. So I know I'll probably set it up, at least in this kind of simple equation, I've set it up right. Does that make sense? You're checking yourself before you even do the math, okay? I've got the units of measurement left that measure what I'm trying to find. Does that make sense? Well, now we're ready to put it in the calculator.
All right. Let's put it in. Stick it in.
Well, let's see here. We got 7.75 times 2.55.
That's a coincidence.
Hit
man.
enter and divide by 1.47.
I got a new phone so we can
Does that
see
mean we
it.
need to upgrade to get the graphing calculators?
No. You can still use the regular scientific calculators, but this is going to make your life easier if you have it here because I can see what I've done.
What'd you do with the TI-82?
I still got it. This is actually a student who left theirs here last week, and I'll have to give it back to her when she
It
gets in
reminds me
here.
of my robot. They got like the old robots and then they put them away and they bring
Right.
out new robots.
Right. I actually had a TI-84. Was a TI? No, I had a TI-82. I loaned it to my son. He broke it. I know. All right. So here we go. 13.4438 7755.
Right.
With units we have left is torr,
Yep, torque.
and that equals pressure 2. Now we're ready to round off. So I look back in the problem and I see how many digits I have in each of these values. These are all measured numbers, so they're all going to matter here. So I have 3 in each of these numbers, so I need 3 in my final answer. So I'm going to underline everything after the first 3 digits
13.4.
and round it off, showing an arrow.
Yep, right.
Okay, and we have 13.4. Let's write that in black. 13.4 torr
Torque.
equals our pressure 2. That's what we're looking for, and we're done. Okay? So that's the process I want you to use to solve all these gas law problems. Yes, ma'am?
Could we have done like P1, V1 equals like K and found the constant and then do P2, V2 equals K?
P2V2, that's like R2D2. Let's label as R and D, so that way it'll be R2D2.
Yeah, but you're really doing more work that way. What?
It's doing the same thing because you get like 19.76 something
Mm-hmm.
divided by 1.4.
Yeah, but you're really doing more work that way.
You guys did Mr.
Overachiever.
Kind of out of the scope.
Let me think now.
That's out of the scope.
Seriously, you should seriously think about labeling it as R and D. That way it'll be R2D2.
Okay. Let's. Does that seem particularly hard?
How do you measure torque?
So let's get out your test references. Get out your test references, and see if you can find this equation listed on your test reference.
Okay.
How do you measure torque? You measure torque with a pressure gauge.
Yep. You sure do.